Hello and welcome. Thank you for clicking on the help video. In this example, we have the function f of x is defined as -4 times x minus 2 to the second power minus 3. And our objective here is to find the value of the inverse, not the function, the inverse at -67. So we're not going to plug in this -67 into the x. We want to plug it into the inverse of f. Now, one option is to solve this equation and find what the inverse function is for this example. Or what we can do is that we have to define this again. All we can do is just simply evaluate this at that specific value. If we do the latter, it will be a lot easier and more convenient to do. So what we have to think about is what does it mean to have the inverse of a function? In very simple terms, that means that, again, that the inverse and how the inverse and the function are correlated or related is that they interchange the independent and dependent variable. The x and quote unquote x and y values are going to switch. Which means that since our objective is to do this, we know that this is going to equal to some number, we'll call it question mark, okay? Then that means that that same number, when plugged into this function here, plugged into that specific x, has to equal to the value of -67. So to find out this number here, that's the equivalency of figuring out the number that needs to be plugged inside here to get this output value, to get this output value. So we're solving essentially, we're solving an equation for the function f. So we're solving this equation here. So if I replace again f of x with its values, which is -4, x minus 2 to the second power minus 3, and setting that equal to -67, the solution to this equation will be the value of our inverse at that number -67. So now that we set it up, how do we solve this? Well, to solve this, we'll start by adding 3 to both sides. And -4 times x minus 2 to the second power equals -64. We're going to divide that -64 by this outside number of -4 since we're multiplying that -4. And we can distribute because of the square. So just divide it. And we end up with x minus 2 squared equals positive 16. And before I can add the 2, I need to get rid of that exponent. And to get rid of that exponent, we will take the roots. So the square root of both sides. So x minus 2, we'll get rid of the parentheses, and the square root cancel themselves out. And the square root of 16 will be 8. Now, normally we would have to consider both a positive and -8, but the problem doesn't set up this. But we have to assume that we're only looking at values of x that are going to be greater than or equal to +2 or maybe less than. We're only going to look at one side of this quadratic. So we're not going to consider, again, both positive and negative. So we're going to only get one possible solution. We'll assume again that they meant to do this. So this was going to be positive 4, like I said, not 8. The square root of 16 is 4. So we're going to end up with 4. So the only thing left to do here is to add this 2 to both sides. So I'm going to add 2 here, add 2 here. And therefore x equals to, well, 4 plus 2 is 6. So there, that is the number. So if I evaluate this function at 6, again, replace this number with 6 according to this solution that I got, that should give me the output value of -67. And because the inverse, again, is going to switch these values, switch the x and the y, that would mean that f inverse at -67 has to give me the output value of 6. So there is your answer. How cool is that?